Okay, we're going to take a look at some simple topics all having to do with electrons so that we can get at an understanding of how atoms bond together. So we're going to look at valence electrons. Those are the important electrons in an atom. We're going to look at how we can represent those visually with using something called a Lewis electron dot structure. And then finally, we're going to see about ions, because ions are really some of the beginnings of learning about chemical bonding. Okay, so let's start with valence electrons. Definition of valence electrons: these are the electrons that are involved in bonding. Okay, they're the highest energy electrons in an atom. The general idea is this: the more energy an electron has, the further away from the atom's core or nucleus it is. So these electrons, because they have the highest energy in the atom, they're also the farthest away from the nucleus. They're on the outside of the atom. The most electrons, the valence electrons that you can have is 8. Okay? That's the maximum. So you're going to have 1 through 8 valence electrons. If you have less than 8 valence electrons, you are an unstable atom. Okay? Even if you're neutral, that's an important point. You should write that down. Okay? Even if an atom has the same number of protons and electrons and is neutral, it may not be stable if it has less than 8 valence electrons. Okay? There's only one group of elements that has 8 valence electrons. We'll see in just a minute, and they don't react. They're very stable. You probably already know what they are, but we'll see them in just a second. The way that an atom can get its 8 valence electrons so it can become stable is it can either lose some if it has a couple extra, it can gain some if it just needs a couple, or it can share with another atom. But whatever it does, its goal is to get 8 valence electrons. This is called the Lewis octet rule. Octet means 8. So the Lewis octet rule in really simple language is all atoms want 8 valence electrons, and they will do whatever they can to get those 8. Now if they already have 8, then they have nothing to do and they don't react. Okay? Now, how we figure out how many valence electrons an atom has is very simple. We look at the periodic table. I've chosen a periodic table that has both the international and American ways of numbering the table, and I did that intentionally. We really are only going to talk about the representative or main group elements. Those are elements in groups 1, 2, 13, 14, 15, 16, 17, and 18. Or, if you prefer, groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. The tall columns. The number of valence electrons for an atom in one of those columns is equivalent to the number of the group it's in if it has an A after it. So all of the elements in group 1A have 1 valence electron. All the elements in group 2A have 2 valence electrons. All the elements in group 3A have 3 valence electrons, and so on and so forth. So the only group of elements that have 8 valence electrons are the elements in group 8A, and those are called the noble gases. And we already know the noble gases don't react. The reason they don't react is because they are stable already. They don't need any more electrons. They've already got 8. Except for helium. Helium only has 2. Why is helium a noble gas if it doesn't have 8? Special case. Helium's the only one that doesn't need 8 to be stable. Okay? So, if I were to say, for example, how many valence electrons does chlorine have? You would go find chlorine, Cl, number 17. You would say, oh, chlorine is in group 7A. It has 7. Now, what if you have a periodic table that doesn't conveniently have the 1A, 2A, 3A, etc.? All you have to do is count from the left to the right and skip all the transition metals. So chlorine is in the 7th group over if you skip the transition metals. And that's how you'll have it. Okay? Very simple to do. Now, we can show the valence electrons in a very unique way in chemistry. We can draw something called a Lewis electron dot structure. It's very simple to do. It's a simple way to show the valence electrons, and those are the ones that are important. So we want to show them. We use the chemical symbol, and we put dots around that symbol. Okay? The number of dots is equal to the number of valence electrons. Now, there's one little trick to it. You don't just put the dots anywhere. You have to follow a little pattern to get the arrangement. And I'm going to show you what that looks like right now. It's a very simple pattern to follow, okay? But you have to do it, because if you don't do it, then you won't have the right arrangement of dots. And if you don't have the right arrangement of dots, you won't really know what's going to happen with it, okay? So let's take an example of drawing some Lewis electron dot structures. Okay, I'm going to draw a Lewis electron dot structure for the element chlorine. I just said that chlorine has 7 valence electrons. I looked that up on the periodic table. All right, I need to know that so that I know how many dots to put down. That's 7 dots that I need to put around this symbol Cl. Okay, here's the way I do it. I start on, I'm going to imagine for a second that this has an imaginary square around it. So it has 4 sides. It's got a top, a bottom, a left, and a right. Okay? I'm going to start on any one of those 4 sides, and I'm going to put a pair of dots. It does not matter where you start. All it matters is that you start with a pair. Okay? So there's 2 of my 7. Now I'm going to put 1 dot on the remaining 3 sides, and then go back and pair until I'm done. So that's 2, 3, 4, 5, 6, 7. So the way that the 7 dots in chlorine are arranged are 1, 2, 3 pairs and 1 unpaired electron. And I know right now that chlorine is going to do almost anything it can possibly do to get 1 more electron to pair up with this one to make it stable. Chlorine is really reactive. I also know that chlorine might share a pair of electrons and form 1 covalent bond, but we'll talk about that later. Okay? If I wanted to do another one, let's say I wanted to do magnesium. Okay? I go and find magnesium on the periodic table. Go ahead and look. You can rewind the video if you have to go find the periodic table. Okay? So the number of electrons that magnesium has is 2. It has 2 valence electrons. We know that because it is in group 2A. Okay? 2 valence electrons. All of the atoms in that group have 2. So that's 2 dots. I follow the same rule that I just told you. Pick any one of the sides and start with 2. Oh, I'm done. That's what magnesium's dot structure looks like. How about nitrogen? N. How many dots do I need to put in for nitrogen? Go look it up. You're right, 5 dots. So I start on any one side. I'm going to start on the bottom. There's my 2. Put 1 on each other remaining side. 3, 4, 5. And that's nitrogen's dot structure. Pretty simple, okay? You need to practice, but it's pretty easy. All right, so now we know how to figure out how many valence electrons an atom has. We know how to draw it in a dot structure. We know that atoms are only stable when they have 8. And we know that sometimes atoms don't have 8. And so that in order to become stable, they will try to get 8. Well, a couple of the ways that they can do this is by gaining or losing electrons. They can either give up some if they have extra, or they can take some if they have not enough. Okay? If they lose or gain electrons, they form what's called an ion. An ion is a charged atom or a group of atoms. We'll talk about the groups later. For right now, we're going to pretend they're just single atoms that get a charge. Okay? There's 2 ways that you can make an ion. You can either lose 1 or more electrons, that's a cation, or you can gain 1 or more electrons, that's an anion. Okay? Those are the only 2 ways that you can do it. Atoms will do whatever is the least amount of energy, whichever is easiest. Okay? So if you have 2 electrons, 2 valence electrons, you could either lose 2 or you could gain 6. Well, it's easier to lose the 2, and you'll be stable that way, so it'll lose 2. An atom never, ever, ever gains or loses protons. Why? Why don't we ever gain or lose protons? You're right, because that changes the atom into something else. It changes it into a different element, and we're not interested in that anymore. Okay? So, the 2 types of ions. We have a cation. This is not pronounced cation. It's pronounced cation, like meow, cation. Okay? Cations are positively charged. They have a positive charge. Well, the only way they can get a positively charged is if they lost electrons. So cations are formed by losing 1 or more electrons. They lose the electrons, atoms, to become more stable. And the elements that do this are metals. Metals will lose electrons to become stable. They will become cations. The other type of ion is called an anion. Not an anion, not an onion, but an anion. Anions are negatively charged. The way you become negatively charged is you gain extra electrons. So these will take on some electrons. And they gain electrons to become more stable, just like the metals did when losing them. Nonmetals are usually the ones that gain electrons. Now, when you form an anion, you have to change the name of that substance now. The name of the element changes. It ends in IDE. Cations don't do that, but anions do. Okay? So let's get a look at a couple of examples and see how this works. Okay, let's take an example, magnesium, that we had again. We already knew from the previous example that magnesium has 2 dots. It's a metal. Now, does that mean that it only has 2 electrons? Well, no. Magnesium has 12 electrons. It just has 2 that are the outermost, the highest energy. Okay? Here's a little secret about metals. If I lose these 2 electrons, I don't have no electrons. I have 10. But in my outermost layer, my new outermost layer, after I lose these 2, I'll have 8. So even though it's going to look like I have no electrons left, I really have 8 when a metal loses its electrons, its valence electrons. The metal will gain 8. That's why it does it. So magnesium is going to lose 2 electrons. I'm going to take these 2 dots right away. I'm going to write magnesium symbol now. And now that I've lost 2 electrons, that means that I have a +2 charge. Okay, first thing you need to understand is this is the opposite of what you've learned in math. Okay? In math, you've learned that the word lose means negative or subtraction. But think about what it is we're losing. We're losing negatively charged things. So that's going to result in a positive charge. And because I lost 2, I write Mg plus 2. This is called the magnesium ion. Okay? Now let's go back to chlorine. We already know that chlorine had 7 dots. It had 2, 3, 4, 5, 6, 7. Okay, it looked like this. Chlorine almost has 8. It just has to get 1 more. That's really easy. So chlorine is going to gain 1 electron. Okay? And that's going to give it a -1 charge. So chlorine now will have 8 dots around it because it had 7 and I just gave it 1 more. But it's also going to have a minus charge above it. Just like we wrote the +2 charge for magnesium, we write a minus charge. You can write -1, it's okay. Usually if there's just 1, I don't write the 1. Okay? Now I don't call this chlorine anymore because it's an anion. Anions change their name. So this is now called chloride. Chloride is the name. Chloride. Okay? So metals, this is just called the magnesium ion. Nonmetals, I change it to IDE at the end. This is called the chloride ion. Okay? So it takes a little bit of practice, but with practice you will get this. It's not that difficult. Figure out what the charge is on an ion by how many electrons it either loses or gains. Drawing electron dot structures, figuring out how many valence electrons. It takes practice. Practice at it, you'll get good at it. This is the basics of what we call ionic bonding, and we'll learn about that next time.